Good morning all. So in last class we were analyzing the graphs Z and W. So we obtained the form of solution curve in the form of this curve C3. So we were analyzing this graph. Now let us see a few more results using this graph. So the next result we will show that is as t increases, the corresponding point xy on C3 moves around the curve in a counterclockwise direction. So the curve is traced along counterclockwise direction. So x ഉം y ഉം വേരി ചെയ്യുന്നതിനനുസരിച്ച് x വേരി ചെയ്യുന്നതിനനുസരിച്ച് y യുടെ വാല്യൂവിന് വരുന്ന ചേഞ്ച് that will be traced along this curve in the clockwise direction. So let's see how do we get that. So for that we will be using these two equations. So dx by dt was ax minus dxy and dy by dt was dxy minus cy. So I can write it as minus y by d, taken yd outside, so we'll get c by d minus x. Mean we have taken the functions z and w. So this is the value of z and this is the value of w. So we have seen from the graph that at a the function z has a maximum. Meaning our maximum point in a y coordinate, this coordinate, whatever is this coordinate, that will be same as one of the coordinates of s, and same way one of the coordinates of s will be the minimum value of C2. So the coordinates of s will be obtained once you know the coordinates of a and b. So we can actually find out this point s using the maximum value of the graph of z and the minimum value of the graph of w. Now by using that technique we obtain the coordinates of s to be x equal to c by d and y equal to a by b. So that is using the coordinates of maximum and minimum of the functions z and w. So we will not be doing that, we will just prove that the direction is in the counterclockwise direction. So for that we will use the coordinates of s. So s will be having coordinates x equal to c by d and y equal to a by b. And now we have the equations of dx by dt and dy by dt. So dx by dt and dy by dt represents the components of the velocity. So they will be the vertical and horizontal components of the velocity, because we are finding the rate of change of x and y. So what we need to show that is as t increases, C3 moves along the counterclockwise direction. So let us look at what is the change in the direction. So how is your dx by dt and dy by dt changing along the graph. So we have the coordinates of s. So s will be having coordinates c by d and a by b. So this point will be x equal to c by d. So along this portion you have x less than c by d, and here we have x greater than c by d. Now if you look at the case where x is less than c by d, so when you take x less than c by d, now d is positive because x is less than c by d. So c by d minus x is going to be equal to positive. So this is positive. Since y is the number of boxes, we know that y is also positive. So dy by dt is going to be negative. So since the derivative is negative, so the curve will be traced in this direction. So it will be going down. So when x is less than c by d, so it will be going down. So it will be traced in the direction q to p1, q1. Now similarly, when x is greater than c by d, so you can see that when x is greater than c by d, so this whole term becomes negative. Now negative into, now these two are positive, so negative into negative, that will be positive. So therefore, when x is greater than c by d, this will be moving in the increasing direction. So that is going to be this direction. So it will be moving in the direction of q1, p2, q2. So this actually gives that c3 is traced along in the counterclockwise direction. So that completes the assertion. So as t changes, the curve C3 is traced along in the counterclockwise direction. And now let us look at the method of linearization of the given problem. So the Fox-Krabbe problem, or the Walter-Espiritu equation, that is a nonlinear equation. Now it can be approximated by a linear equation, and hence we can obtain the solution. നമ്മൾ already linear equation solution എങ്ങനെയാണ് കണ്ടുപിടിക്കുന്നത് ചെയ്തിട്ടുണ്ട്. So this problem can be approximated into linear equation, and hence we can look for the solution to, or approximate to the solution of this kind of problem. So let us see the method of linearization. And now we know the coordinates of S. So S is this point, so the coordinate of S will be C by D and A by B. Now if you look at the equation, dx by dt can be written as dx into AB minus y, and dy by dt can be written as minus yd cd minus x. So at the point S, which is C by D, have coordinates C by D and A by B. So when you substitute the coordinates x and y into this equation, you can see that both the equations become 0. So we'll get dx by dt equal to 0 and dy by dt is equal to 0. So this actually means when the number of rabbits is C by D and the number of foxes is A by B, then in that case dx by dt will be 0 and dy by dt is 0. That means there is neither no increase or no decrease in the population of foxes and rabbits when you are having the coordinates to be C by D and A by B. അതായത് ഫോക്കസിന്റെയും റാബിറ്റ്സിന്റെയും എണ്ണം മാറുന്നില്ല, provided x is C by D and y is equal to A by B. Now this is some kind of equilibrium solution. So അതായത് ആ വാല്യൂ ആണെങ്കിൽ അതിനകത്ത് നമുക്ക് ചേഞ്ചസ് ഒന്നും വരുന്നില്ല. So such a value is called the equilibrium value. So when x is C by D and y equal to A by B, the system is satisfied, and we have dx by dt and dy by dt equal to 0. So there is no increase or no decrease in x or y. So the populations with these values are called equilibrium populations for x and y. So they can maintain themselves infinitely at these constant levels. Now let us see how do we linearize this problem. So നമ്മുടെ സിസ്റ്റം ഒരിക്കലും ആ ഒരു സ്റ്റേബിൾ സ്റ്റേറ്റിൽ ഇരിക്കില്ല. there will be variations in the values of x and y. So from the equilibrium position there can be some variation. So we take those variations to be capital X and capital Y. So let the actual population be x equal to C by D plus capital X and y equal to A by B plus capital Y. Okay, so C by D and A by B, they are equilibrium values. Equilibrium values in the deviations and now. So that deviations is taken as x and y. So x and y can be thought of as a deviations from their equilibrium variables. And now let us replace x by c by d plus x and y by a by b plus y in our equation. So let's see what do we get. Using a substitution, x equal to c by d plus capital X and y equal to a by b plus capital Y. So let us substitute that into the first equation, dx by dt equal to ax minus bxy. Now dx by dt, c by d is a constant, so therefore dx by dt will be equal to d capital X by dt. So the left side will be d capital X by dt, and on the right side we will get a into c by d plus x minus b into c by d plus x into a by b plus y. Now expand the second term. So upon multiplying, we will be getting this. So we will get ac by d plus ax minus b times ac by bd plus cy by d plus ax by b plus xy. So upon simplifying, ac by d and ax will cancel out. So remaining we will have minus bc by d into capital Y minus b capital X into y. So that will be dx by dt, and similarly dy by dt is dxy minus cy. Again y by dt will be equal to d capital Y by dt, since a by b is a constant. So substituting x and y, we will get d times c by d plus x into a by b plus y minus c times a by b plus y. So upon multiplying, this is what we get. So cy and ac by b will cancel off, and remaining we will be getting ad capital X by b plus b capital X into y. So we will be getting these two equations. So when you take x equal to c by d plus x and y equal to a by b plus y, so we will get d capital X by dt and dy by dt to be these. Now let us take the deviations x and y to be really small. So when they are small, when you take the product xy, so that will be almost negligible. So we can omit this term. So when you omit the term containing xy, so we will be getting dx by dt equal to minus bc by d into y and dy by dt equal to adx by b, which is linear. So this equation can be reduced to a linear form using this approximation. So we have seen that x and y are negligible, so our equation is approximately linear. So this is the linear form we will be getting. So assuming x and y are small, so xy is discarded without serious error. So therefore we will finally get dx by dt equal to minus bc by dy and dy by dt equal to ad by b into x. And now we can take dx by dt, so divide both the equations. Sorry, that will give so we can divide these two equations, so we can obtain dy by dx from this. So dy by dx is going to be equal to minus ad square x by b square cy. Now we know that this equation is in a variable separable form, so upon solving we will get the solution in the form ad square x square plus b square c y square equal to c square, where this is an arbitrary constant. So this is an equation of an ellipse. So therefore the solution curves can be approximated by family of ellipses. So as the arbitrary constants vary, we will get family of ellipses. അപ്പം നമ്മുടെ solution curve നമ്മൾ oval shapeലാണ് കണ്ടത്. Now when we use a method of linearization that reduces in the form of a family of ellipses.